All right, next up, HVAC 4. Where did you pull the humidity ratio for air at 10 degrees and 50% RH? The provided psychrometric chart does not provide state points for temperatures that low. That is true. We used to have it in the old days in the mechanical engineering reference manual, but we do not have a low temperature psychrometric chart in the reference handbook. So what do you do if you have a situation like this where it's 10 degrees? And the answer is you go right below the psychrometric chart. There's a table. And that table is called thermodynamic properties of moist air. Probably the fastest way to find it is just search psychrometric chart and then scroll down 2 or 3 pages and you'll get to this table. And on that table, it's not a psychrometric chart, so you can't identify specific state points on it. But what it tells you is that for every temperature of air, it makes a little table. So let's say you care about 10 degrees. It gives you the humidity ratio at saturation, which means that if it was 100% humidity at 10 degrees, this would be some number. I don't know the number, blah, 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 pounds per pound of dry air. And of course, that's not what we want in this problem. We want 50%. So you can do a little bit of a sly hack here. You can just take 50% of that number. And that's not technically exactly right, but it's more than close enough for all intents and purposes. So, if this number is 0.0002, then for 50%, you're going to take 0.0001. And that will do for 10 degrees and 50% humidity. Just assume it's linear in that range, for really low temperatures like this, and you'll be fine. Another thing you could do, this is even more. So if that bothers you because you like to be really precise, then you're really going to hate this idea, which is you can just pretend there's no moisture. Because as we know, when air gets very, very cold, its capacity to hold moisture is reduced substantially. So if it's that cold, then it can barely hold any moisture at all. And it's only holding 50% of what it could if it was saturated. So it's only half saturated and it's really cold. So we can just say that it's a rounding error. And I think I mentioned this in the solution video too. The humidity ratio is approximately 0. And if you do that, not only does it make it faster to solve the problem, it'll be close enough. It'll be really simple to solve. So I would invite you, not only to the person who asked this question, but to anyone who wants to go back, if you've already passed the HVAC module, and just take a second look at HVAC 4 and just try on the idea that you may not need to trouble yourself with looking up the humidity ratio at low temperature. Just see what happens if you assume there's no moisture at all. I would hate for you to get a problem on the PE exam where you're getting stuck on this and spending time and trying to make the decision and not knowing if it's linear or not. Can I interpolate, or not even finding this table in the first place, when you just as easily could have said, you know what, that air is so cold that its moisture content is basically a rounding error, and I'm just going to ignore it. Something to consider.